चलो स्टार्ट करते हैं. Before we start the lecture, few announcement, guys. As you all know that we are going on app with so many things. These were my sessions of this month, and these 2 sessions are left. If you want to practice GATE previous year questions from gas power cycle and vapor power cycle, do not forget to join these sessions on 30 and 31st at 5:30 p.m. How can you join these sessions? By downloading the app. If you are not on the app, download the app. You can download the app by scanning this QR code. QR code को scan करो, ठीक है? Or you can also type in this link. Now, if still it does not work, then what you can do? Below this video, you can see the description. In the description, you can see this link directly. Okay, this link. So you can go and directly, it will be directed to the app. If you are not on the app, if you are on the app, then good and well, you can join the lecture anyway. Okay. And guys, of course, these sessions are for someone who have done things, okay, who have done proper syllabus. But if you have not done your syllabus properly, and if you want a crash course or want us to guide you, then you can join these crash courses. Okay, we have just started our crash course. You can join. I am teaching thermodynamics. I will be taking entire thermal basically. It is a very structured course. Okay, we have live classes, recorded lectures, everything, basically everything that is required to sit for GATE exam. Whatever is required for, whatever element is required for the GATE preparation, it is there. It is there included. Okay, study material, mock test, practice quizzes. And also, if you want to prepare for GATE 2025 or 26, then we are here for you. Okay, we are already planning these batches, so do join these batches as soon as possible. We'll start early, finish early basically. Okay, chalo. And guys, if you have not joined my Telegram channel and you want to connect with me directly, join this Telegram channel, Mechanical by Vipin Yadav, or you can just scan this QR code, or you can search. No, this is only questions, Baba. Narendra, it is just ISRO level question, okay? So it is not, we are not covering theory here. We are covering basic ISRO level questions, that's all. We will be practicing questions, that's all, okay? Not the theory part of it, okay? And also, reciprocating compressors is not important for your GATE exam anyway. Okay, you don't require reciprocating compressors, centrifugal compressors for GATE exam. Very less questions come. Actually, very rarely they ask questions. For your GATE exam, your Breton cycle and vapor power cycle is more than enough basically. Okay. Chalo. Let me give you a brief introduction about me, and then let's start the session. So guys, I have 6+ years of teaching experience. For ISRO you need reciprocating compressor. So let's try to solve the questions. I'll try to explain if required. Okay, chalo. So I have 6+ years of teaching experience. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. I think you all know this if you are watching me on YouTube, on app. Okay, so I have 3.5 years of industry and research experience, and my area of expertise is basic and applied thermodynamics. Chalo, start karte hain session. Let's start with the very first question. So, intercooling in multi-stage compression reduces. When you do intercooling, you do between 2 compressor stages, yes or no? This is one compressor. Then you will apply your combustion chamber, then turbine. This is your intercooler. Yes, so it reduces the work required in the compression. Yes, otherwise, basically pressure you need to increase anyway. Okay, index of compression, no, it reduces the work input to compressor. Simple. which valves are provided in reciprocating compressors? You see, inlet valve, exhaust valve, which type of valves provided in the compressor? Yes, Narendra, Deepak, that is correct. Now, which type of valves are provided in the reciprocating compressors, inlet and exhaust valve? Yes, it is plate type, spring controlled. Valves. Sometimes we also call it REIT. Okay, yes, plate type. Okay. Yeah, it is plate type. Okay. Now, air is compressed in a single stage reciprocating compressor at the rate of, this is mass flow rate. Now it is compressing, you are compressing it from 1 bar. T1 is 27. 2P2 is equals to 8 bar. Gamma is given 1.4. R is given, and take 8. I think it will be ln 8. I think ln 8 will be this. Okay, 8 to the power. Okay, ठीक है, ठीक है. A to the power, this is 1.812 and ln 8 is this. Difference in work required if compression was isentropic and isothermal. So you need to find out when the compression is isentropic, how much work you will get, and then when compression is isothermal, how much work you will get, and you have to subtract it. So how you are going to do it? Any idea? By work. Very simply, we have defined work when process is isentropic. What is it? It is gamma upon gamma minus 1. Yes, P1 V1 and P2 by P1. Gamma minus 1 by gamma minus 1. This is your isentropic. Isothermal, what will be isothermal? Isothermal will be P1 V1 ln V1 by V2. Simply. Or V1 by V2 को what can you write? You can write P2 by P1 as well. So you know everything. You know everything. Calculate quickly. You need V1 only. V1. How can you calculate V1? By ideal gas equation P1 V1 M R T1. V1 is equals to 1, 0.285, T1 is 22. 22 is how much? 295. It is 1 bar, means 1 into 10 to the power 2. So you will find 0.846 meter cube. Now quickly calculate heat work. How much you are going to get? What is the difference? Quickly calculate. Tell me how much is work in isentropic. Then tell me how much is work in isothermal. And then calculate the difference. Put all the values, guys. You have 1.4. Are you solving it? Are you solving it? This, if you put all the values, you will get around 240. And when you put all these values, you will get around 175. So if you subtract it, you will get, they are asking difference in work. So work of isentropic minus work of isothermal will be equal to 65. Yes, it is isothermal, no, Baba. This is isothermal work. This is your isothermal work. Yes, temperature is constant. It is V2 by V1. If it is V2 by V1, Baba, that's what you are saying. So that is always work output. It is always work output. Okay. But it is work of compression. It is work of compression. So it will be V1 by V2. And V1 by V2, if you change, it will be P2 by P1. Simple. Understood? What equation you are saying, it is work output, but this is work input, work of compression. Got it? Didn't get it? Look, when you write work it like this, it is P1 V1 ln V2 by V1. Yes, that is true. What you are saying is true. But this is work output. For example, if you use this equation for a turbine going through isothermal process, then it is correct. But here it is a compressor, it is a reciprocating compressor. And in this compressor, you will be giving this work. If you giving this work, so work input will be minus P1 V1 ln V2 by V1. Or you can write, sir, P1 V1 ln V1 by V2. Okay. Now it is an isothermal process. If it is an isothermal process, means P1 V1 is equals to P2 V2. Okay. So I can write V1 by V2 is equals to P2 by P1. So I can replace this by this. Simple. What is there? Nothing. It is basic thermodynamics. Okay. Chalo. Now the compressor can deliver maximum theoretical volume of air known as. How much theoretical volume your compressor can deliver? How much air it can take theoretically? Total volume, free volume, swept plus clearance volume. What do you think is the answer? Guys, answer quickly. Maximum theoretical volume of air that can come in the compressor. It is swept volume na baba. Because clearance so you cannot use anyway. Yes, swept volume. That is the theoretical. But because of clearance, your swept volume is more, but actual air or actual volume occupied by the fresh charge or fresh air is less. So actual volume is less than swept volume. Okay. So, but this is a theoretical volume. Now, the pressure volume diagram of a ideal reciprocating air compressor consist of? What is the ideal? How many processes it takes? You see, first of all, there is suction, constant pressure, 0 to 1. Then there is isentropic compression, 1 to 2. And there is constant pressure, exhaust, delivery, you can say 2 to 3. And if I have to make a cycle out of it, because thermodynamic cycle must be closed, so I have to come back here and this will be constant volume. So now how many processes? Sir, 2 isobaric, 1 adiabatic and 1 constant volume. Yes or no? Yes, A is correct. Very good. Next, in suction, compression and delivery of the air takes place on one side of the piston, only then the compressor is known as. What do you call the compressor in which suction, compression, delivery only happens on one side? If this is your piston, suction, piston will move with that like this. Suction will only happen here, compression will happen, delivery will happen like this. So this will called as single acting compressor. But if you have a compressor like this and you also have an exhaust valve and an inlet valve here, so mass can also come in like this and mass can also go like this. That means when the piston will move this side, it will compress the mass here, and when it will move back, it will compress the mass here. It is called as double acting. So when it will only happen on one side, what is it? Single acting. I don't understand what you are saying. V initial is equals to V final. I don't know. Maybe it is from centrifugal compressors. Okay. Maybe it is from centrifugal compressors, but not here. Not reciprocating. Okay. Chalo. So what is this? This is single acting. Single acting. If only one side is happening, it is single acting. If both sides it's happening, it's double acting. Okay. Chalo. Intake air filters are provided in the compressor primarily. We use intake air filters. So when air enters into compressor, we use filter before it. Why do we use filter before it? Why do we use filter before it? Why do we use filter, Baba? Yeah, no, not moisture. For moisture, we have after cooler. Only dirt. Remove only dirt. That's all. Air filter is only for dirt. Filter, how can it remove moisture? Okay. So only dirt. Then we have after cooler to remove moisture. It is to remove moisture. Okay. So removal of moisture after cooler. After compression, we have after cooler to remove if there is any moisture in the compressed air. Before you send it to your boiler or combustion chamber, you remove all the moisture. So after cooler is removal of moisture. Okay, chalo. Single stage piston compressors are used to compress air up to the pressure of approximately. Single stage piston compressor are used to compress air up to pressure of what? Up to what pressure? Yes, up to 5. Basically, single stage if you are using, you are going to only compress around 5 to 6, not more than that. 5 to 6 maximum. So it can be 5, 5.5, anything. Okay. So single stage is around 5 to 6 and double stage is up to 6 to 35 bar. Then we have triple stage up to 180 bar. Up to 180 bar. Okay. So 5. Next. Circulating water around the cylinder which helps the air to cool during compression is called. What do we call? We have a jack. I have told you answer. We have a circulating water around the cylinder that is used to maintain. Yes, no problem, Baba. I don't know. You can check the lectures that I have taken. Okay. But I don't know if, because that is in ESC batch. Yes, water jacket. So there is a jacket around the cylinder and it has water in it. Its work is to reduce the temperature. If the temperature goes beyond design limit, it will absorb the heat to maintain the, not in YouTube, Baba. It's in app. Okay. So water jacket. In reciprocating compressors, the clearance ratio is generally it's not available in YouTube, Baba. It's in app. Chalo. The clearance ratio is in what range? Guys, clearance ratio has a drastic effect on the volumetric efficiency. As you increase the clearance volume, your efficiency drastically decreases. Volumetric efficiency. But still you need clearance volume. Why? No. Minimum 4 to 10, not more than that. 4 to 10. In fact, even 10 is very high. But this is the minimum range that they have given us. Okay. Yes, A is correct. The cooler placed in between stages of a reciprocating compressor. So we know. Intercooler. We have solved this. The work input of a compressor is minimum when the law followed by the compression is PV 1.35 is equals to constant, PV gamma is equals to constant, PV is equals to constant, or PV 1.25 is equals to constant. Gamma assuming is 1.4, let's say. Yes, C is correct. Isothermal, it should be isothermal. This will be isothermal. This will be polytropic. This will be PV gamma is equals to constant. PVN is equals to constant. PV is equals to constant. So this work is minimum. Area below the curve is minimum. So work is minimum. Isothermal. In actual compressors, there is a clearance between the cylinder head and piston to take care of the thermal expansion. What is the correct expression from the given options? So you have to understand clearance volume is very, very less basically. And your length is swept, or stroke length, let us say stroke length. And I don't know if you know, but let me tell you, it is given by this equation. It is very less, but good enough to account for the thermal expansion. Okay, so 0.005 of that stroke length plus 0.5 you add it. Okay. In reciprocating air compressors, the clearance ratio is, what is the clearance ratio? C. What is the clearance ratio? Yes, clearance volume by swept volume. Very good. That is the clearance ratio. Volumetric efficiency of a reciprocating compressor is not dependent on which of the following factors? It is not dependent on which of the following factor? So what is your volumetric efficiency? 1 plus C minus C RP 1 by N or 1 by gamma, whatever you want to call it. RP is what? Pressure ratio, P2 by P1. RP is P2 by P1. Yes or no? Yes. So it is based on clearance ratio. Yes. It is based on polytropic index. Yes. Pressure ratio. Yes. But it is not dependent on air receiver. So the answer is air receiver. Yes, very good. Very good. The multi-stage compression of air as compared to single stage compression. If you are doing multi-staging, why are you doing multi-staging? It improves volumetric efficiency for the given pressure ratio, increases work done per kg of air, does not improve volumetric efficiency, give less uniform torque. Why do you do multi-staging, Baba? Yes, exactly. Because when you have to work at much higher pressure differences, then because of clearance ratio, your volumetric efficiency drastically decreases. The pressure ratio increases, your volumetric efficiency drastically decreases. So, no. The main purpose is, so work will also increase because the higher you will go. Basically, if you want to maintain, for example, when you are going from 5 to 10 bar, to require less work. But same pressure ratio, but if you are doing between 10 to 15, then it will take more work. Same pressure ratio. Pressure difference basically. So that is also reduced also, but it is saying increases. It is saying increases, okay. Chalo. Yes, to improve volumetric efficiency. The main reason is to improve volumetric efficiency because at higher pressure, at same pressure, yes, okay. If the compression of the air is carried out in large number of stages with perfect intercooling between the stages, then the overall compression approaches. Which process? If you are doing compression, isentropic compression, intercooling, isentropic compression, intercooling, isentropic compression, intercooling, compression, intercooling, compression. So that means earlier you were going like this, now you are going like this. So this process is almost isothermal. This is TS diagram, it is almost isothermal. So if you do infinite number of stages, you will have the isothermal process. You will have isothermal process. Okay, chalo. The work done in compressing air from stage 1 to stage 2 without clearance volume with standard terminology is what? We have done this question. What is the answer? What is the answer? C. Are you saying C for this or for the last one? Yes, C is correct. N upon N minus 1, P1 V1, P2 by P1, N minus 1 by N minus 1. Very good. Identify the correct statement from the following options. In the multi-stage reciprocating compressor, the process of intercooling yes, both question, yeah. So what is the answer? Yeah, this is also C. Cools the compressed air from each stage before admission to the next stage. Yes. The water jacketing the cylinder of a reciprocating piston cylinder, air compression leads to the. If you are using water jacketing or water jacket to cool the piston cylinder, what will happen? Why do you use water jacket? Yes, C is correct. C is correct. Rajput. Yes, Dhanesh. Chalo. B no C. B no C. ये वाला बताओ फटाफट. No, not for that. Always remember, a lot of people have this confusion that in reciprocating compressor you give clearance to give the valves some space to operate. A lot of people have this confusion. What is the confusion? That valves need some space to operate. That's why you give clearance volume. No. Usually in reciprocating compressor, okay. Usually in reciprocating compressor, valves are not inside, they are outside. They are plate type valve outside. This is spring controlled. So they will open and close outside only. They will not require space from inside. Then why do you do clearance? You give clearance to accommodate for the thermal expansion of the piston. Because if the temperature is really high, in the piston, it can expand because of thermal expansion. So if it expands because of thermal expansion, it can go and hit the cylinder wall. Okay, it can go and hit the cylinder wall. For example, if this is your piston, so you design your piston maybe something like this, that okay, I am giving no clearance, because usually your valves does not need clearance. Okay, your valves are here outside, they can operate outside easily. You can plan that your piston should stop exactly here, good, no problem. But if temperature is really high, then it can expand. Now if this expands and you have designed according to this, that piston should stop here, and now it is expanded, it is going to hit the piston. This piston is going to hit the cylinder wall, cylinder head, and the cylinder head can go out. So to avoid the damage because of thermal expansion, we give clearance, so that if you design your piston to stop here, now even if thermal expansion is there, it is not going to hit the cylinder head. Okay, now there is one more thing that can happen. What? There is one more thing that can happen. What? If it is expanding in all the directions, means temperature is really high. If temperature is really high, it can expand, volumetric expansion. If it is expanding volumetrically, then you have given enough space for the piston to travel, because you can't give much space between piston and wall, cylinder wall, because leakage can happen. But if your piston has expanded, then it can, now it is not able to move in the piston, in the cylinder, and therefore seizure can also happen. Means the piston will cease to move in the cylinder due to thermal expansion, and it is happening because of high temperature in the cylinder. So that's why you also apply water jacket. That's why you also apply water jacket. Okay, so water jacket is to maintain a design temperature in the cylinder, so that piston will not have high thermal expansion and it will not stop moving. Okay, so A is the answer. A is the answer. Okay, chalo. In a two-stage reciprocating air compressor, the suction and delivery pressure are 1 and 4 bar. For maximum efficiency, the intercooler pressure is, what is the intercooler pressure? For maximum efficiency, you will work at perfect intercooling, and you will get intermediate pressure as initial pressure into final pressure. That means 1 into 4, and that means 4, that means 2. Intermediate pressure will be 2. So intercooler work at this pressure, intermediate pressure. It will work at this intermediate pressure. Got it? Chalo. What is the unsteady to and fro motion of the piston causes pulsation in the engine compressor known as? You should answer this, guys. It is important phenomena that happens in compressor. Because of that, mass will go forward then come back, go forward and come back. To and fro motion will happen. Why this happens? What is this phenomena called? What is this called, Baba? It is called as surging. Surging. Okay. Nahi, not pulsing is not a word here. This pressure ratio, and this is mass flow rate opening. So if you work below this, if your mass flow rate, if you operate in this region, then pressure ratio starts decreasing. So in your compressor, somewhere it's higher pressure, somewhere it's lower pressure, and mass always flows from high pressure to low pressure. So your mass will come down, come back towards the inlet valve, and then when mass will come here, mass flow rate increase, so pressure will increase, mass will again go ahead, then again come back, then again go ahead, then again come back. That is called as surging. That is called as surging. It is the to and fro motion of the fluid, and when to and fro motion happens, it is called pulsation. Okay, but pulsing is not the right word, we do not use this. Okay, chalo. An ideal gas compressor cycle with clearance, on PV diagram, how do we represent on PV diagram with clearance? With clearance is this. होती है, बिल्कुल होती है, क्यों नहीं होती? Suction, compression, exhaust, expansion. Surging and choking both happens in reciprocating compressor. Choking is when you open your valve, but after a limit your mass flow rate does not increase. That is your choking. Surging is when pressure gradient is unfavorable. That means at the inlet pressure is lower, at the outlet pressure is higher. So mass flow rate will flow back towards the inlet. That is surging. चलो ये बताओ फटाफट. So we have two isentropic process and two constant pressure process. So what is the answer? Two adiabatic and two isobaric. B is the answer. Yes or no? Yes. Chalo. Least work input for air compressor. Least work input will be needed if the compressor is hyperbolic, isentropic, polytropic, isothermal. दुनिया जहां जानती है कि मिनिमम वर्क कहां मिलेगा? आइसोथर्मल. पता है ना, अभी शुरू में भी क्या था ये क्वेश्चन, ये वाला डायग्राम भी बना के दिखाया था, आइसोथर्मल क्यों मिलेगा. ठीक है. क्लियर है? यस, डी इज करेक्ट. चलो, वेरी गुड. So we have reached the end of this session. Around 30 questions we have done, and they are all ISRO, BEL, HAL level questions. Okay, basically PSU level questions. Okay, and guys, from yesterday only, from today only, we have started formula memory test. Very innovative series we have started, and today at 8:30 p.m. Dheeraj sir and Abhinav Negi sir will be taking this session. And very innovative series guys, do not forget to join. हाँ, ये रहेगी. बाकी टेलीग्राम ग्रुप ज्वाइन कर लो, ये वाली पीडीएफ पीपीटी भेज दूंगा इसी की. ठीक है, चलो. एंड देन दिस इज द फर्दर शेड्यूल. 27 आई विल टेक थर्मोडायनेमिक्स ऑन 30 October 30. Okay, so do join me at 9 p.m. and then this is the schedule that you can check for mechanical engineering. And guys, if you have not joined the app, join the app, because there is so much going on. The scholarship test you can sit on 22nd. Okay, it is already done. This, I think I need to change this slide, but again we are the next session scholarship test will be uploaded soon. Okay, and guys, again, mock test is an integral part of your GATE preparation, so do not forget to attempt mock test. And we are also coming up with mock test series. So this is the schedule for mock test. So for more details, again you can call BYJU'S exam prep and ask for details. Chalo. Very good. And guys, if you have not joined my Telegram channel, join the Telegram channel. I will share this PPT there. Okay. So either you can scan this. You can scan this or you can just search mechanical by Vipin Yadav. ठीक है, चलो, very well. I will share the PPT on Telegram group and I will see you very soon in the next session. And also join my free app class sessions. So for that you need to download the app. If you have not downloaded, please download it. Okay. 30 यानी कि Monday and Tuesday I will be taking Baraton cycle gate PYQs and Rankine cycle PYQs. So if you want to practice your gas power cycle and vapor power cycle PYQs, do join me on Monday and Tuesday 5:30 p.m. on free app. Okay. If you are in my Telegram group, I will also share the link later. But again, join the app. Okay. Join the app by clicking on this link, or still you can get the link here. Okay. In below this video, you can check the link. On third, fourth line, you will get this link. Click on this link. You will be directed to download the app. Okay. If you are not on the app, if you are there, well and good. Chalo. ठीक है. Chalo guys. Then I will see you very soon in the next class, next session like this. Thank you. Bye bye.